Hello and welcome back. We will continue with section 5.1, looking at solving systems of equations. We did one example of this before, let's do another. So we'll solve this system of equations using the addition method. So first and foremost, we'll recognize that these two equations are not in standard form, as in they don't look like ax plus by is equal to c. So in order to do that, let's put all of the x's and y's on the left-hand side and all of the constant terms on the right-hand side. So for instance, in this top equation, the x is already on the left-hand side, but the y isn't. So to change that, I'll just subtract 3y from both sides. When I subtract it from the right-hand side, I'll just be left with 9. And when I subtract it from the other side, I'll have 2x minus 3y. Cool. On the bottom equation, I have my x is on the right-hand side, so I want to add 3x. This should be a y. So when I add 3x to both sides, that will cancel, and I'll just be left with the 8. And on the other side, I'll be adding the 3x, and I'll have the 4y as well. So when we're using the addition method, we want our terms to cancel when we add them up. So when we add the 2x and the 3x, we get 5x, that hasn't canceled. When we add the the negative 3y and the 4y, they almost cancel, but I still have a y left over. So to combat that, what I will do is I will multiply the top equation by 4 and the bottom equation by 3. How did I choose 4 and 3? Well, when I multiply the top equation by 4, in particular, 4 times negative 3y is negative 12y, and on the bottom, the 3 times the 4y is 12y. Negative 12 and 12 cancel. So that's how I chose 4 and 3, is to make the y terms cancel. So let's distribute. So across the top, 4 times 2x is 8x. 4 times negative 3y is negative 12y. And 4 times 9 is 36. On the bottom, we've got 3 times x is 9x. 3 times 4y is 12y. And 3 times 8 is 24. Now we can add these together. And we get 8x plus 9x is 17x. Negative 12y and 12y, those cancel. That adds up to 0. And on the other side, 36 plus 24 is 60. Nice. Now I have this equation. Let's rewrite it over here. I can divide both sides by 17 to get that x is going to be 60 17ths. This is not the nicest number here. It's a pretty horrible fraction, but this is going to be our solution. There's not much that we can do about it. So let's plug this back in. What I will do is I will substitute this back in to one of my original equations. So let's use the bottom one here. So I have 4y is equal to 8 minus 3 times x, and x we know is 60 17ths. So let's rewrite this. I have 8, which I'm going to write as a fraction since we'll have some fractions. So this is 8 over 1 minus 3. I'm going to write this as a fraction, 3 over 1, just to make things nice. And then I'm multiplying this by 60 17ths. So first and foremost, the first thing that I will do is multiply these two fractions. So I'm going to be subtracting 3 times 60 is 180, and 1 times 17 is just 17. In order to subtract or add fractions, they have to be over the same denominator, the same common denominator. So I'll multiply the top and the bottom of this fraction by 17. So I have 8 times 17 is 136. 1 times 17 is 17. We're going to subtract 180. these are things that a calculator would easily be able to do. And then if we simplify this side, this will be negative 44/17. So let's collect ourselves. Let's simplify this. So on the left-hand side, I have 4y. And after I simplified the right-hand side, I had negative 44/17. I can divide both sides by 4. And when I divide a fraction by 4, it's the same thing as multiplying by a fourth. So again, I have 44/17 times 1/4. I can cancel a 4 and a 4 to be left with 11. So y is going to be negative 11/17. My solution is going to be 60/17 negative 11/17. This is quite a lot of work with fractions, but the most important step is right here. It's recognizing not everything is in standard form, so we put it in standard form. And then recognizing our terms don't cancel. So I multiplied the top by 4 and the bottom by 3 so that my y terms would cancel. I could do the same thing and get my x terms to cancel as well, and I should come up with the same solutions. In any case, we can find our solution, and it would be good to plug it back in and to check, but that's a lot of fractions to deal with. So one question that I think is very, very important is just how many solutions can a system of equations have? Thus far, we've only been finding one solution. The question is, does every system of equations have one solution? Could they have more than one solution? Could they have no solutions? So linear equations, as we've been graphing them, so something like ax plus by is equal to c. This is called linear because it graphs as a straight line. And if we have two linear equations, we have two straight lines. So their solution is going to be where they intersect. We could have, it is possible to have one solution. And this corresponds to our lines intersecting in one point. Now, not every pair of lines will intersect. We have seen this before. For instance, we could have parallel lines. So here, when we look at where they intersect, these two lines will never meet, and so that means that there is no solution. There is never a pair of numbers that will satisfy both of the equations. So we could have no solutions. And then what this means is we have parallel lines. And the last situation, which maybe isn't as obvious right now, but we could have two equations that give the same line. Now we can see where do two of the same line overlap? Where do they intersect? Well, they intersect everywhere. The entire line is then a solution. So we could have infinitely many. And the only time that this happens is if our two equations give us the same line. So there are three situations. We can have two lines that intersect at exactly one point. Quite often this is going to be the case. We could have two lines that never intersect, and therefore there are no solutions. Or we could have two lines that are exactly the same, at which point they overlap everywhere, and there are infinitely many points along the line. So let's take a look at what happens in these situations. So let's solve this system of equations. We've got 5x minus 2y is equal to 4, and negative 10x plus 4y is equal to 7. The top nearly cancels with the bottom, but the top looks like it's about half of the bottom. So for instance, the 5x and the negative 10x, if I multiply the top by 2, we'll see that we'll get 10x and negative 10x, and those should cancel. So let's multiply this top by 2. 2 times 5x is 10x. 2 times negative 2y would be negative 4y. And 2 times 4 is 8. And then the bottom, I'll have negative 10x plus 4y is equal to 7. I didn't multiply the bottom equation by anything. So what happens when I add these two guys together? 10x and negative 10x, well, that just adds up to 0. Negative 4y and 4y, that adds up to 0. And on this side, I've got 8 and 7, and that adds up to 15. And right here, this should be ringing some alarm bells. 0 plus 0 is 0. And 0 is not equal to 15. So, what went wrong? The answer is nothing went wrong. This just means there are no solutions. If we were to take the time and to graph these two equations, we would see that both of them, that these are parallel lines that never intersect. So maybe I can graph this right here. If we were to put this into mx plus b form, both of these would have slope 2/5, but they pass through the y-axis at different points. So they're both at slope 2/5, so they're going up, but somewhat slowly. And they will pass through the y-axis at different points. They are parallel lines. They will never intersect. There are no solutions. So if you ever, as we're doing this, we found 0 is equal to 15, or maybe in a different scenario, we get 1 is equal to 2, or we get something that's just clearly not true, that means that there will be no solutions. We couldn't solve for x here. We just got numbers equal to numbers that aren't themselves. So there are no solutions. Let's finally take a look at this system of equations. We've got x is equal to 4y minus 8, 5x minus 20y is equal to negative 40. The top equation isn't in standard form, so let's move the 4y to the other side. So I'll subtract 4y from both sides. X minus 4y is equal to negative 8. And 5x minus 20y is equal to negative 40. And what we'll start to notice is at the top and the bottom, the top looks like exactly 1/5 of the bottom. So let's multiply the top by negative 5. And by multiplying by negative 5, we will start to see things cancel. So x times negative 5 is negative 5x. Negative 4y and negative 5 is 20y. And negative 8 and 5 is 40. On the bottom, we've got 5x minus 20y is equal to negative 40. And now things will cancel. But what we'll notice is that 5x and negative 5x, that adds up to 0. 20y and negative 20y, that adds up to 0. 40 and negative 40, well, that adds up to 0. And 0 is equal to 0. What happened to x and y? They disappeared when we added them. So this means infinitely many solutions.